Section 20.3 Side angle side congruence theorem. If two sides and the included angle of one triangle are congruent to two sides of the and the included angle of another triangle, then the triangles are congruent. Forgive me, I can't spell. Congruent. So here we've got a side and a side. Here we've got an angle and an angle. And here we have another side and another side. Hence, SAS, or side angle side. So let's take a look at an example. We've got triangle DEF, and we also have triangle let's see, GHJ. So I do the little trick of labeling it like, 1, 2, and 3, and 1, 2, and 3. And let's take a look. Between D and E, we have to ask ourselves, is that congruent to G and H? Right, otherwise known as 1 and 2 and 1 and 2. Are these the same measure? 30 and 30 they are. So here's one of our sides. What about the angle? Is angle E, right here, and angle H, are they the same? Well, one's 95. This is a right angle of 90. So these are not the same. And now let's take a look at this other side. We've got side EF and we've got side HJ. Are they the same? They are both 40. So those are congruent. But right, we have a side and a side, but we do not have an angle, right? So this would be triangle DEF is basically not congruent to triangle GHJ. And the reason is, we don't have a side angle side condition here. So let's take a look at another example. And I'll give you a moment to get caught up on the notes. So here's another example. And you have basically two triangles. You got triangle ABC, and you have triangle ABD. Make it D correctly. And if I just do the 1, 2, 3 trick, right? 1, 2, 3, 1, 2, 3. It's pretty easy to see which sides correspond to which sides. CB corresponds to DB. And we have to ask ourselves, are these measurements the same? They are the same. So these are congruent. So I have the S of my side angle side theorem, right? I have one side is congruent to one side. And now let's take a look at the angles. We've got angle ABC, and that's this thing right here. And I'll use a different color for the other angle. You've got angle ABD, and are they the same measure? Well, We know this is a right angle because of that little box right there. That tells us this is a right angle. And right angles measure 90 degrees. And anytime you got a situation like this, right, this is basically a linear pair. So if this is 90, whatever this is has to add up to 180. So what's 180 minus 90? Also 90. So this has to be 90. So now we ask ourselves the question, are these two angles the same? They are. So now we've met the angle condition of our side angle side theorem. And now let's take a look at AB. Right? AB, I'm going to erase this stuff from the angle right here so you can see. Now we're talking about AB. And AB is right here. And don't the two triangles share this side? The answer is yes, right? Would you say AB is the same as AB? I would. So no matter what, even though it doesn't actually list a measurement, right? There's no measurement here. No measurement. We can all agree, though, that, right, no matter what measurement it actually would be, wouldn't AB be the same as AB? And the answer is yes, it would be, because they share a side. I think this would be like the reflexive property of equality, but in simpler terms, right, AB is the same as AB. So this satisfies the third condition. Side angle side. So basically these two triangles are definitely congruent, and they are congruent because the side angle side theorem. So I'll give you a moment to get caught up. Hopefully this is making sense, and we'll move on to the next page of the guided notes. So here we have triangle DEF, and we have triangle GHJ, and we're trying to figure out if they're congruent. Well, let's try to see if we can find two sides that are the same with an included angle that's the same and another side that's the same. So if I label these 1, 2, 3, and I label this other one 1, 2, 3. The reason I do this is, again, just so I can tell which parts correspond to which parts. We're gonna now try to figure out, well, are these sides the same? We're probably going to be looking at this side, this angle, and that side. And here we're probably going to be looking at this side, that angle, and this side. So let's take a look at DE. Side DE corresponds with side GH, and we have to ask ourselves, are they the same measurement? They are. So these two things are congruent. So first part, we have a side that's the same. What about the angle? We're talking about that angle there and that angle there. That symbol, right, anytime you see something like this, that symbol indicates that the two angles are the same. So we basically have angle FDE, and FDE corresponds with, right, I go 312 with 312, JGH. And there are more than one way to write this particular angle, but I picked this way. And I've got these two symbols that I talked about. So these two angles definitely congruent. So there's my angle in the side angle side theorem. And now we got to check the last side. And that would be side DF and side GJ. One is 1.7, the other is 1.7. 1.7 is the same as 1.7. Definitely congruent. So the original question, are these two triangles congruent? The answer is yes, they are congruent, and the reason is because of the side angle side theorem. So we'll do one more example, and then we'll move on to the MyHRW exercises. So then this next example, we're going to try to figure out what the variable would equal if these two triangles were in fact congruent by the side angle side theorem. So let's see if we can find our sides. And one side, AB, right, this one right here, that looks like it's congruent with PR. So AB and PR are congruent. They're the same measurement. And now let's see, right, we're trying to find our other side. Our other side is right here. BC and RQ. BC and RQ. So let's see, BC and RQ. Looks like BC is congruent to RQ. So now the only thing we're trying to figure out is how much does this angle measure? And how much does this angle measure? Well, first of all, you have to know that inside a triangle, you write this neatly, inside a triangle, there are 180 degrees. And so basically the measure of this angle is going to be equal to 180 minus 60 minus 67. So once you figure that out, I think you wind up with a measure like 113 degrees. So we've got 180 minus 60 minus 67. Nope, not 113. What was I thinking? It's 53. That's way off. $53. So if this is 53 degrees, and this angle and that angle are supposed to be the same, right? How much is x? Well, let's find out. 2x plus 17 is equal to 53. Subtract 17 from both sides. 53 minus 17 is 36. So 2x is equal to 36. Divide both sides by 2. X is equal to 18 degrees. So that's that example. Give you a moment to catch up. Or at least I know I write pretty fast. It's easy to write fast with one of these electronic pencils. And now I'm going to move on to the rest of the guided notes. Here's another example, right? We're trying to use side angle side. So I'm just coloring the sides I'm even talking about. And by coloring the sides I'm talking about, it kind of helps me at least approach this problem in an intelligent manner, where I try to figure out, well, it looks like I'm trying to figure out an angle measure, at least if I'm using side angle side. And the reason I say an angle measure is because, well, I have two sides listed, but I don't know what the angle is, angle C or angle F. So let's take a look. We've got basically AC. It's definitely congruent to DF. And we have CB is congruent to FE. So here's our side. Here's our side. All we need is our angle. And we're talking about the measure of angle ACB and the measure of angle DFE. All right, side, angle, side. So if these two angles are supposed to be the same, make them the same. You simply set the two things equal to each other to solve for x. So from here, solve for x. I subtract 2x from both sides, and I get 14 is equal to 2x. Then I divide both sides by 2, so x must be 7. And if I plug 7 back in, right, I'm going to get 2 times 7 plus 14. Is that the same as 4 times 7? If it is, I probably did it right. 14, 2 times 7 is 14. So 14 plus 14, is that the same as 4 times 7, which is 28? And the answer is yes. So I've checked my answer, and I wind up, this angle is 28 degrees, and this angle is 28 degrees. So from here, we're going to go to the classwork / homework assignment, and this will conclude our guided notes for this section.